Okay, now we need to take the derivative from electric field intensity with respect to time. Second derivative. Okay, first let me write 1 over v squared. Second derivative from dt squared x multiplied 100 multiplied by cosine 10 to the power 6 t minus square root of mu 0 epsilon 0 10 to the power 6 z. Okay, if we take a second derivative, 1 over v squared multiplied, we have x multiplied 100 multiplied second derivative with respect to time, 10 to the power 12 multiplied minus, so here minus will be minus, okay, 12, yep, minus cosine 10 to 6 t minus 10 to 6 mu 0 epsilon 0 z. Okay, well, okay, and we should take the this value and this value by equation. So by equation it was d squared e over dz squared minus 1 over v squared d squared e over dt squared should be equal to 0. Okay, d squared e over dz squared is equal to this minus x 10 to the 14 mu 0 epsilon 0, so minus x 10 to the 14 mu 0 epsilon 0 multiplied by cosine. Well, now I will not write the argument of cosine because argument of cosine in both cases is the same. I think it will be clear in this way also. And the d square e over dt square here minus 1 over v squared. Okay, minus 1 over v squared. With this minus we get plus 1 over v squared multiplied by x 10 to the 14 multiplied by x 10 to the 14 multiplied by cosine. Again, I'm not writing the argument because the argument is the same, equal to 0. And now we can simplify cosine we can simplify unit vector x. We can simplify 10 to the power 14. And what we get is minus mu 0 epsilon 0 plus 1 over v squared equal to 0. From here, v equal to 1 over square root of mu 0 epsilon 0. And now, what about the numeric value of v? So, numeric value of v equal to 1 over mu 0 epsilon 0. So, mu 0, permeability of empty spaces, 1.256 and 6 multiplied 10 to the minus 6. And electric permittivity of empty space, epsilon 0, is 8.854 10 to the power of minus 12 equals to, okay, 1.2566 multiplied 8.854 equals, and square root of this, and 1 over x is, so 0.2998 multiplied 10 to the power of minus 18 minus 9 plus 9, 10 to the power of 9 meter per second, or it is approximately 3 10 to the 8 meter per second, and it is, well, speed of light, and is denoted by c. Okay, now the second part of the exercise. Now we finished first part of the exercise. What about the second part of the exercise? Show that this solution is of the same form as in equation 12.3, and equation 12.3 is this. So our solution, which is this, is exactly in the same form as this function. So how can we prove this? Okay, let me copy this. Copy. This solution should be exactly in the form of yxt equals, which is gx plus vt, or no, x minus vt plus f x plus vt, should be in the form of this. Now, in order to prove that our solution is in this form, we need to manipulate a bit our solution. Sorry, electric field equal to, now I will write here 100 cosine 10 to the 6 t minus 10 to the 6 square root of mu 0 epsilon 0 z. Now, in the cosine, we may take this term and put it out of the bracket. So it will be equal to x multiplied 100 multiplied by cosine. This term is minus 10 to the power 6 multiplied square root of mu 0 epsilon 0, and we get z minus t over, so t over mu 0 epsilon 0, and is equal so we know that 1 over square root of 1 over square root of mu 0 epsilon 0 is v in our case, and here instead of 1 over square root of mu 0 epsilon 0 we put v, and we get equal to x multiplied 100 multiplied by cosine minus 10 to the 6 mu 0 epsilon 0 minus 10 to the 6 multiplied square root of mu 0 epsilon 0 is constant, equals to no yes in the bracket z minus vt. And now we can see that our function is exactly in the form of first function, where the function g is in our case cosine, and in this case the argument is x minus vt. In our case the argument is z minus vt, and we can see we can see that we have demonstrated that our solution is exactly in this form, where the second function is 0 and first function is this. Okay, and now the next question, the last question in our case: what is the direction of propagation of the wave? Well, we can see that our equation, the electric field has a component only along x, or it means it is alternating along x direction. However, however, the direction of propagation, the direction of propagation of the wave can be determined from comparison of electric field intensity with the general solution, which is which was the in the previous case. The general solution is so y x t. The general solution of our equation wave equation was y x t g x minus vt plus f x plus vt. Okay, the direction of propagation can be determined from comparison of our function or our solution, in our case electric field, with the general solution. This is the general solution. In this case, the direction of propagation is in z direction. So we have written that electric field was equal in previous page. We said electric field is equal to uh, x multiplied by 100 cosine. So x multiplied by 100 cosine. Okay, 10 to minus 10 to 6 mu 0 epsilon 0 minus 10 to 6 mu 0 epsilon 0 of z minus vt, z minus vt, or we can write this as x multiplied as some function g of this argument z minus vt. Here, okay, first we look to our general solution. In our general solution, here x shows the direction of propagation, and v is speed of propagation, and t is time. Okay, is simply time. We go back to our function here or here. We can see that instead of x here we have z minus z minus vt. It means that the direction of propagation in our case is in z direction. Okay. Direction of propagation in this case is in z direction. So did you understand the logic? First we take our solution and we write it in we write it in the same form as general solution. Here is general solution, and the arguments show us the direction of propagation, the speed of and the speed of propagation. That's it. So did you understand here in the last point the logic, how to define the direction of propagation?
Düşünerler
Okay, if you have understood, that's great.
Set.
Okay, have a rest. Tomorrow we will start solving electromagnetic wave equation. In this case, today and yesterday we have seen wave equations in general cases. Tomorrow we will see application of this wave equation in electromagnetic waves. And mostly we will deal with Maxwell's equations.
Düşünerler söz. Rahmet.